Asia with high performance and advanced GIS technologies. And today, this webinar aims to introduce the latest SuperMap GIS technologies, especially for big data, artificial intelligence, 3D. So initially, we planned this webinar actually to GIS professionals in KSA. However, according to the current the registration participants, we are also pleased to have friends from all the other neighboring countries online with us. So we hope this webinar will help create a chance for us all to exchange ideas and good practices in using GIS technologies. And also, it will be much appreciated if you can share your inputs and comments during and after this webinar with our team, and to help us provide more and a better webinar in the future. So I wish it will be a very successful webinar today. Thank you.
Okay.
Okay, thank you, Evelyn, for your speech. So please welcome Mr. Joid Mohammed as Business Development Manager from Vision Intelligence to give us a short speech. Time is yours, Mr. Ali.
Okay, thank you, Evelyn. Thank you for your introduction. I would like to speak in Arabic. بسم الله والصلاة والسلام على أشرف خلق الله سيدنا محمد وعليه أفضل الصلاة وأتم التسليم. أرحب بكم في هذه العجالة لإلقاء الضوء على المعلومات الجيوميكانية الذكية وخدماتها المساندة. كما نعلم أن التقدم الرقمي في مجال الحاسب الآلي والذكاء الاصطناعي وتطبيقاته وعلم البيانات وتحليلها وارتباطها بجميع مجالات الحياة وخاصة النواحي التي تعتمد عليها عمليات اتخاذ القرار وذلك باستخدام بيانات ومعلومات متعددة صحيحة ودقيقة، فإن القرارات المعتمدة عليها تكون على درجة عالية من الصحة والدقة. إن الخدمات التي نقوم بها في ذكاء الرؤية سواء التنفيذية أو الاستشارية لإدارة البيانات وتحليلها وهندستها هو تطويع لتقنيات إدارة البيانات والمعلومات الجيومكانية وتطبيقاتها وتكاملها مع الذكاء المكاني وتطبيق مجالات التقنية فيها، بحيث نجعلها خاضعة للقياس ومعرفة الأداء والتطوير المستمر واتخاذ القرارات الذكية في المكان والوقت المناسب. ومن الأعمال التي نقوم بها في علم البيانات والذكاء المكاني وما نحن بصدده هو استخدام وتسخير تقنيات الذكاء المكاني لتكون تفاعلية وآنية من خلال نظم المعلومات الجيومكانية المعروفة بجيوسبيشال انفورميشن سيستم، وهو نظام يعمل على جمع وإدخال ومعالجة وتحليل وعرض وإخراج المعلومات المكانية والوصفية لأهداف محددة، وتساعد على التخطيط واتخاذ القرار فيما يتعلق بالتحليل المكاني وعرضه بالوسائل المختلفة. هذا النظام الذي يقوم على تحويل البيانات إلى معلومات مفيدة ذات معنى، بحيث يتم التعامل مع أعداد هائلة من المعلومات وتحليلها وربطها بالمكان مجال البحث والتحليل لمساعدة المؤسسات والقطاعات العامة منها والخاصة في تحديد وتطوير أساليب اتخاذ القرار الصائب. وتتلخص خدماتنا الجيومكانية في ذكاء الرؤية في الاستشارات الجيومكانية وبناء الاستراتيجيات وخارطة الطريق لبناء منظومات ومراكز التميز الرقمي، الحلول الجيومكانية الذكية الشاملة، المسح والتصوير الجوي بمختلف وسائله والمسح البحري ورسم وإنتاج الخرائط بمختلف الوسائط، الأعمال المساحية المرافق والخدمات، المساحة العقارية، حلول وخدمات الاستشعار عن بعد وصور الأقمار الصناعية، حلول البيانات والمعلومات الجيومكانية الضخمة، وضبط وضمان الجودة للمشاريع الجيومكانية والتدريب ونقل المعرفة. إن المحور الأساسي والتوجه المهم هو عن البدائل وتساعد في توسيع الآفاق وفتح المعرفة تجاه تطبيقات وحلول جيومكانية ذكية بدأت تنتشر تقديم نبذة تعريفية عنها وعن الحلول الذكية في مجال المعلومات والبيانات الجيومكانية. Thank you, Evelyn. Thank you for all participants. And I would like this webinar will give a clear introduction about SuperMap solutions and services in geospatial intelligence. Thank you.
Okay, thank you, Mr. Joit, for your speech. So now we will have one speech before we start the presentation from Mr. Ali Aldoseri as the President of Saudi Geographical Society and the lecturer in the King Saud Arabia University. So please welcome Mr. Ali. You can give your speech.
Thank you. Hi to everyone. I would like to say a small words in Arabic. If you allow me, then I will back to you in English. بسم الله الرحمن الرحيم والصلاة والسلام على أشرف الأنبياء والمرسلين. الجمعية الجغرافية السعودية تسعد بتنظيم ورشة عمل حول برنامج سوبر ماب، وهو من البرامج الرائدة، ولديهم في هذه البرمجيات تقنيات عالية في التحليل الذكاء الاصطناعي في مجال المدن كنموذج في هذه الورشة. والجمعية وأنتم جزء منها تنشط في جميع المجالات البحثية والعلمية وإثراء المعرفة وإلقاء الضوء على البرمجيات الحديثة والاتجاهات العالمية. وهذه الورشة ثمرة من ثمرات الاتفاقية التي تم عقدها مع شركة ذكاء الرؤية قبل تقريبا شهرين، وكان هذه من أحد الثمرات التي أو بدايات التعاون في إقامة ورش عمل مشتركة وتعاون تكاملي يخدم القطاعين. فنرحب بكم من جديد ولن نطيل عليكم، وشكرا لكم على حضوركم ومشاركتكم معنا في هذا اللقاء. Dear ladies and gentlemen, thank you very much for your attending, and it is a great honor to be with you and making this effort of the webinar as a workshop. And the Saudi Geographical Society has a great effort in the Kingdom of Saudi Arabia and also in as well as Arabic countries to provide the knowledge and transfer the knowledge of technologies, geographic softwares, geographic information, remote sensing technologies, plus artificial technologies, as we are looking forward to see in your workshop. Again, it is a great honor to be with you today. Jason, Vella, Firdaus, thank you very much for your effort and making this workshop happen. And we're looking forward for further cooperation. Thank you again.
All right. So thank you, Mr. Ali, for your speech. Yeah, of course, we do hope we can gain collaboration in the future. So now, without any further ado, we will start the webinar. Start with my presentation about the SuperMap company profile. And should you, all of the participants are allowed to drop your question in the Q&A chat box. So if you have any questions related with our presentation, you can put your question in the Q&A chat box, and we will have a short Q&A session in the last presentation. So we will try to answer your question in live session, but maybe not all of them. The rest we will try to answer your question by email, perhaps. Okay, okay, now let me try share my screen. Okay, so good day everyone. Welcome to the SuperMap webinar in the King Saudi of Arabia. And first presentation will be delivered by me, the company profile of SuperMap software. let me introduce you myself, just a brief. So my name is Firdausi Zaragandis. I'm the technical support in Asia and Oceania Center SuperMap Software Co. Ltd. And today I was delighted to speak here as a speaker and host as well. Okay, without any further introduction, let me try to tell you about the outline of my presentation today. It consists of 4 parts. The first one is company profile, SuperMap 5 main key technologies, SuperMap products, and the last one is SuperMap collaboration opportunities for organization in the KSA. Okay, let's start with the first one is the company profile. So maybe some of you or mostly all of you is not familiar with our software. So SuperMap is a GIS software company that was founded in the 1997. We are coming from Beijing, China, and we have contributed in GIS sector for 23 years. And then we have more than 4,000 employees spreading in all around the world. Already gained more than 1,000 partners that coming from more than 30 countries. And we have 38 branch offices and subsidiaries that's spreading in worldwide. And regarding our technology, you don't need to be hesitated because we already certified by trusted organization. Okay, now for a moment, let's take a look this graphic. So as we can see here, this graphic is show us about the technological developments, which until now we often talk about Industry 4.0 in the term of GIS, are examples of developments accessed in terms of maturity and future feasibility. So I think from various providers, not only SuperMap, they are definitely trying to develop toward a GIS that follows technological developments, starting from the blockchain GIS integration, AI GIS or artificial intelligence, big data GIS, new 3D GIS, cloud, and also the cross-platform. And all of these points will be the SuperMap 5 main key technologies that I will deliver after this. Okay, the next part is about the SuperMap 5 main key technologies. So these 5 main key technologies have very important roles as a main foundation for our products in solving many kind of problems. Start with the first one is the big data GIS, artificial intelligence and GIS integration, new 3D dimension GIS, distributed GIS system technology, and the last one is the cross-platform GIS. So these 5 main key technologies, we use to abbreviate it into the BDC. Okay, now let's take a look one by one. Every key technologies, I will try to introduce you what is that and also a brief example. Okay, start with the first one is the big data GIS. So in the SuperMap itself, the big data was found in 2017 and it has 2 directions. The first one is spatial big data and the second one is the distributed reconstruction of classic spatial data. So SuperMap Big Data support to stream, store, analyze, and visualize large data. Just like in the video, in this slide presentation, we try to meet the visualization of location data streams such as the real-time or historical location display, tray playback, and target monitoring for aircraft, vehicles, ships, and etc. And then the other one is we also able to handle massive data, of course, because big data is handle massive data. And this demonstration system is based on the SuperMap distributed GIS and Alibaba distributed database PolarDB. So it achieved high performance managing and visualizing of over 2 billion records of aircraft locations. And the data was live streamed and visualized in real time, all done in a high performance. Okay. The next key technologies is artificial intelligence and GIS integration. So mostly all of this function done by these key technologies is to do the object feature detection, such as in the left picture, as you can see, we're trying to do the trace counting, and the right picture is we're trying to do the building extraction. So all of done using our products. It was like you only need to import your data in our software and then create the training model, and the rest process to do the object feature detection was done by the SuperMap software. The other capability last part of our my presentation is about the AI technology to do the estimation of house price affected by infrastructure. So our artificial intelligence technology is not only capable to do the detection, object detection, but also can do the further analysis for a massive data. And then the others is also AI interaction. So in the AI interaction, we are capable to meet the visualization of our map refer to the body movement. So it will be it will give you more experience in understanding your data, of course. And then the next key technologies is the SuperMap 3D GIS integration. So as you can see here in the figure displayed, the new 3D GIS technology systems are divided into four main parts, beginning with the 2D and 3D integration data model, which is included the several type of data models such as the 3D point, and then 3D network, 2D network, TIM, TIN, voxel grid, and grid. And then the second part is we have the 2D and 3D integration technologies. So we are not only trying to display our data 2D and 3D separately, but be able to do the integration for both of this data. And also we're capable to consume many kind of data, 3D data. It can be oblique photogrammetry data, BIM, or building information modeling, point cloud, and then 3D field data, and etc. And after we import it in our software, we can give you an output, an interaction by using VR or virtual reality, augmented reality in the WebGL, and also the 3D printing. So this is the four parts of our 3D capabilities: the integration data, able to consume any kind of 3D data, and then we can give you 3D interaction and output in various ways. And then this one show you more details about what data that's supported by SuperMap to be consumed, to be analyzed, and also to be visualized. We support to visualize oblique photogrammetry data, BIM, point cloud, 3D field, and etc. And now let's take a look this video. This video show you about the example of our three-dimensional modeling with its complexity and details. So SuperMap was try to improve your spatial analysis using 3D dimensional visualization. So the analysis function developed specifically for 3D data, such as we support to do the flood analysis, visibility analysis, sunshine rate analysis, and others. So actually this analysis is support in our desktop, but not only in desktop, we support to bring this analysis in web development. And another capability in our 3D is, as you may know, 3D is not only intended to beautify or support visualization, right? So it comes down to analyze and do the identification, just like in this picture, we are trying to do the query for the 3D data. And not only that, we also support to do the legality analysis. So usually in some area there is a vertical and horizontal legality, right? So here we are trying to detect an area of the buildings that violate the rules. So it will no longer, so we can know which building that violate the rules, and it can be very useful for urbanization. And then the others is not only by vertical but also horizontally. And the 3D data can be visualized not only in desktop, not only in website, not only in web platform, but also by using the augmented reality. So here we are trying to raise the experience of the user to see how the data looks like in a real situation. So here we are trying to display the BIM data, or building information modeling data. And then our other capability in 3D is also be able to express the 3D continuous space. So for some data that are intangible means that you cannot see it um, directly in your environment, such as the sunshine rate, noise field, and then geological properties field, and etc. We are capable to do the 3D interpolation for those data and give you a very convenient visualization. This is another example of the voxel grid. So this is the expression of the signal field based on the voxel grid. So the data is in the form of 3D points, and then from those 3D points we can create a 3D interpolation and give you this visualization. Okay, now is about the cloud native GIS. So this is actually part of the SuperMap distributed system technology. So here I will try to give you just a short history about our cloud native capability in the SuperMap. So we are start our cloud technology since 2010, and then this year we just released our new key technologies, that namely the SuperMap distributed system GIS technology, and this cloud native is part of it. So cloud is basically will help you, will support you to do the sharing data, to do the publish your data in online way, to give you more experience in sharing your data, not only for 2D data but also 3D data. So this is part of the distributed GIS. The distributed GIS means that this is a new method of high performance computing, and in the SuperMap itself we have uh, five part of the distributed GIS. The first one is our technology is HGIS technology, high performance, and then cloud native GIS to support you to do the online data sharing, and then distributed geospatial analysis and processing technology, distributed geospatial data engine technology, and the geoblockchain technology. So I will not explain all of this one by one because it will be very technical. So just for your information, in case you're willing to know more about this, you can check our website, you can check our article in LinkedIn and etc. to get to know more about this distributed GIS. So basically this distributed GIS will increase the performance of our software capability to handle many kind of data, to do the processing, to display, visualize, stream 2D and 3D data, and etc. And this is one of the example is the fruit traceability. So their geolocation data can be managed on the blockchain to avoid the tampering. So blockchain is our new key technologies just released in this 2020 in our conference, GTC 2020. And another example is the cadastral parcel management. So it is easy to implement the trace function of parcel changing based on the geo blockchain. So besides, the data like parcel boundary line and the boundary point can be managed by geo blockchain to avoid the malicious modification. And then our last key technologies is the cross-platform. So we support multiple CPU architectures and operating systems. So SuperMap is can be used anywhere, not only in PCs but in mobile, in the cloud, with a quite a variety of operating systems such as Windows and Linux as well. And now let's take a look at the SuperMap product technologies. So this is our product families. We have cloud terminal, edge terminals, PC, web, and also mobile. Okay, let's take a look. I will give you just some points, not all of this terminal, because just to make you easily understand about our products. So the first one is the desktop base. So this is a list of our desktop based product, the iDesktop. We call it iDesktop. And also actually there will be I object here. It can be used for you to do the software development. And iDesktop is can be opened in your not only Windows but also Linux operating system, and it has many kind of rich analysis function, and it can be it can consume not only 2D data but also 3D data, and then not only vector data but raster data as well. And then the AI feature extraction that I have explained to you previously, it can be achieved by using our iDesktop, the iDesktop Java. But iDesktop.NET is not capable to support the AI feature extraction. And then the next one is our cloud base. So in our cloud base, we have three main products. The first one is the server GIS. We have our iServer, and then portal GIS. We have iPortal, and the last one is the Edge GIS. We have iEdge. So server GIS is have a function to do the publish your data into a GIS service, and then you can display your data in the map dashboard using our portal GIS. So our portal GIS is a code free, so you don't need to do any code inside by using this iPortal. And the iEdge is to raise the performance of your iServer. So in case you have more than one server in your system, iEdge can increase the capability of your server. And this is more detail for our iPortal. So in our iPortal, the SuperMap iPortal, we support to do the online mapping, application customize data inside, display your data conveniently in the map dashboard, just like in this presentation, and also big screen. And the next one is the mobile base. So after the desktop based, web based, we have also mobile based application. So it is like mobile applications that have many kind of functions. We can do the AR and AI data collection and also the measurements, and then data collection for surveying, navigation of course, and visualize your 3D data, and then display your data by AR. And it can be more than this. You can try it by your own. You can download the iTablet in the application store, and then you can find out more details about our application in the mobile based terminal. Okay, now SuperMap is also actively gain collaboration with some universities in order to achieve these education activities. So we are not only help many government, many private companies to handle their project, but we also support education in worldwide. So now let's take a look our activities in education. So we have our annual GIS contest, and then we have internship opportunities on site and online, and also the webinar and short course that able to be attended by many students worldwide countries in order to get a better knowledge about SuperMap. So we also actively come to some universities and organize introduction training for them, because of this pandemic situation, we need to hold this, and we are trying to adapt to the situation by organize the training online. And after the university, I will explain to you about the business opportunities in SuperMap. So SuperMap itself has more than 1,000 partners coming from the 30 countries, and it coming from many kind of various company. It can be IT, GIS company, surveying and mapping, or maybe on surveying and mapping, or maybe technology providers and others. And also we have various clients coming from more than 100 countries, and mostly is from government, and but also others like NGO or the non-government organization, and etc. Or maybe research organization. It's also part of our clients. And this slide is show you just an overview about the SuperMap successful cases, the SuperMap successful cases. So as you can see here, we have many kind of collaborations with many countries from Europe, from Asia, from Middle East maybe, but it not a display yet here, and etc. So This is our existing project, just an overview because we have more than this and mostly is in China, but we also gain good relationship with other country as well. And we have our distributor, official distributor in the Korea and also in the Japan, and not only coming from the government but also from the other private company, organizations and university, of course. And this is just an overview about our successful cases. So we already gained many collaboration with the companies to that solve their problem with our key technologies, such as this is mostly in Indonesia. We support to the big data project and then surveying by using our mobile application, AI for the feature extraction and etc. And we also do good collaboration with many universities coming from the not only in Asia but also in other countries. So after we organize introduction training in their university, mostly of them is also gain collaboration with us. So this is more detail about the form of collaboration in SuperMap. We are provide the exclusive distributor and then partner, reseller, and also university partner. So not we are trying to collaborate not only with profit organization but also with education. And what you will get from the cooperation with SuperMap is, of course, you will get the license. We provide the maintenance visit, on-site and online training, troubleshooting services, and etc. And the benefit, it depends by the chosen package in I have told you previously. So last, I will tell you why you need to choose SuperMap, because the first one is we actively update our technology. So as you may know, the geo-blockchain technology is only capable by SuperMap. No other GI platform have these key technologies. And then we offer a full range solution, platform and application, full range framework, and also, of course, our technology is already proved. So that's all for my presentation. Thank you for your attention. And should you have any question, you can drop your question in the Q&A chat box, and we will answer your question later. Thank you. Okay, now we will move to the next session is presentation from Jason, our technical manager. He will present about the SuperMap solution for city development escalation. So please welcome Jason. You can
Hello.
start.
Hello,
Yeah.
can you hear me?
Yeah, we can hear you.
Okay. All right. Now I will share my screen. All right. Good afternoon. Good afternoon, ladies and gentlemen. This is Jason, and here I will start my topic about the SuperMap GIS industry solutions. Before that, I want to introduce myself to all of you. My name is Jason Yuan, and I am the technical manager of SuperMap's GIS software Asia and Oceania Center. So my speech is divided into these 5 parts. They are urban planning, construction, oil and gas, land resource management, and spatial big data. So the first topic is urban planning. Talking about the urban planning, actually here I want to share with you one of our successful cases, which is the geo-design platform of Hong Kong. This project has this 6 objectives, such as to enhance the existing system through establishing 3D GIS planning system with 3D visualization and 3D GIS analysis, and also others. So I think we don't need to explain too much about the objective. Let's go to take a look at the real project. So at first, this is the brief view of the project, and we can see we got all the oblique photographic data of the whole Hong Kong, and we can show them in the 3D WebGIS like this. And we can see the bruise and rendering is very smooth. Okay, so besides of showing the 3D scene in Web.js, there are and also we need to integrate a lot of other data source related to the urban planning, such as the outline zone plan, which is generated by the related department, government department, and we can integrate this data into our system. And also research data visualization in population. And of course, the urban planning has a smooth relationship with the population growth. So we also need to integrate the population data. And also the wind direction visualization from the research institute. Okay, and there are some urban planning functions. The first one is a free drawing. Actually, in this 3D urban planning system, we can draw a building as whatever we want. So suggest we draw a polygon like this, and then inside of this polygon we draw another one, which we can draw it to make it stand up as a building, and we can set the color. We can add more to it. Also, after we draw the, we use the free drawing function to finish all of our design. Of course, this is only a draft design. We can do some related 3D spatial analysis function, such as this one is a 3D view sheet analysis. And we can set a viewpoint of the building we just built, and to create a view sheet analysis like this. And we can show which area we can see from this building, which area we cannot see from it. And the second function is we can also upload the design options. Sometimes or always we don't need to use the JS software to do our design of the building. But we can finish the building in some other software such as CAD or others, and we can upload it to the GeoDesign platform. And we can to test whether is it suitable for us to put a building here. And also we can do the profile analysis like this, which is we can draw a line and cut it, get the cut section, and then we can get the profile of this line. And there are some design parameters. All of those parameters are based on the policy of urban planning of Hong Kong. And we can set some default parameter first. And then here we can see, we can choose to click Add Site and to find a site for us to do the development. After this, we can add more building here. Here are some templates for us to choose to add the blocks. And also we can set the rotation, set the type of the roof shape. And we only need to click to add one building here. And next one is the 3D JS analysis. Based on all of those functions, there are also some other cool 3D JS spatial analysis, such as this one is a 360-degree view sheet analysis. And we can get from that point how much sky we can see, how open is that area. And we can also get the 2D result like this. And the shadow analysis is also very important for the urban planning. We can set a specific time to simulate the position of sun and get the shadow in the application. And the flow analysis can help us to analyze the situation of flow. We can simulate the flow rising, and to check which area will be flowed. And this one is a slope and aspect analysis. It can be based on the terrain, and we can see which area has the shape. And this one is the skyline analysis. Skyline is very important. We can view from the sighted viewpoint and get the comparison between the building, the mountain, and also the new building. And we can see how much the new building will affect the existing skyline. And this is the design option. We can, based on the scene, to add two options of building design at the same time. And we can compare both of them to find a perfect choice. And also we can simulate to drive a car inside of this application, and it can be integrated with the street view. Also, it can be integrated with the scene pictures. And the fly path is a very important function for us to view all of our plan, all of our design. We can set it as whatever we want, and we can save it. And when we want to show it to others, we can also play it again to show it. All right, so this is only a brief introduction of the urban planning. And next, we are going to the second topic, which is SuperMap construction solution. And we mainly do focus on the BIM plus GIS. So first, what is BIM? The BIM is building information modeling, and it is a very important data source for details, and it works very well in the design and implementation stage of a building construction. But during the operation and maintenance, only one BIM is not enough. So we need a GIS environment to contain this independent building, to give it the geographic meaning. And the integration of BIM and GIS can bring us to macro to macro, and from outdoor to indoor. Okay, so here I listed some of the BIM model formats we supported, such as the Autodesk Revit, which is very popular in the construction industry, and also the CATIA, the SketchUp, the Bentley, and also others. Almost all of the BIM formats we can support it in SuperMap. And after we import the BIM model to GIS environment, what can we do? First, here we can, based on the BIM model, to do the 3D spatial calculation with GIS data. So just this one is to based on the road to calculate with the terrain. And the 3D spatial relationship judgment. It can query objects based on query conditions, and the conditions can be contained, separate, concise, intersect, be included, or related. Also, the box section view is important for the construction. We can cut this building as a box and see the detail, see the inside detail of them. Okay, and next is the BIM construction schedule modeling. we can base on our construction schedule to make the monitoring system like this, and we can monitor the real construction progress with the BIM model. And next, there are some real cases we did about the construction, such as this one is a construction management project, and the application scene is the large-scale construction management project. The major business is video monitoring, television construction, and labor monitoring, progress, regulatory, and environmental monitoring, equipment monitoring. And next is transportation facilities management. We based on this data to construct a subway and integrate with the CCTV, integrate with a lot of sensor, and we can monitor the real status of whole construction. Okay, and besides of construction, BIM is also very useful in the operation platform. Such as this one is the maintenance management of super high-rise building. This building is the Shanghai Tower, which is the second highest building over the world, the highest one in Asia, the highest one in China. And of course, we know that the Dubai Tower is the highest building in the world. But this one is the Shanghai Tower is based on the SuperMap GIS software to do the maintenance application. There are the major business are the daily operation, the synthesis, command, the equipment operation, the scheduling policy, and also the reverse 3D visual information platform. It has mainly the functions of BIM data integration with terrain, and BIM and fine terrain integration, the equipment and facilities monitoring management, and also road and bridge management information system. Okay, and now we are going to the third topic, which is SuperMap oil and gas solution. Talking about the oil and gas solution, here I have to divide it into three parts, which is the upstream application, the midstream application, and downstream application. Talking about upstream application, we mainly focus on the geology, the geophysics, the drilling, and ground gathering, such as the oil exploration and development integration data center. Based on this data center, we can do the oil exploration and development. And for the geology, there is oil field geologic study, and it can be shown on a map in a GIS application, and detect oil well application. The mainstream application is mainly focused on the long-length pipeline and also the stations. For the pipeline, we have the general structure of pipeline application, and we can say the base is the data which includes almost all the related data, such as the research and design, the infrastructure, the dynamic monitor. They all combine into the lifecycle data center. And based on this data center, we use the GIS software to publish all of them as service, such as the integrated estimation, the data mining, the log management, the 2D and 3D scene. And based on the platform service, we developed a lot of applications, such as the data management application, the 2D and 3D integration application, and also the pipeline check, pipeline operation applications. There are some cases, such as the intelligent pipelines, and this is about the inspection. It can record the worker who the track of worker to do the maintenance of pipeline. And about the downstream application, we mainly focus on the oil depot and gas station. such as the land terminal 3D emergency management system. This is mainly focused on the stations, and it has the functions of view and check factory sites, equipment, and workflow in an all-round way, as well as contingency plan, simulation exercises, emergency training, disaster prediction, and others. And this is another treatment plant 3D emergency system. And it has the functions of view and check factory sites, equipment, and also others. And we can make the pre-plan for it. Okay. We call it as one map. For the one map, this is the architecture of it. The basic is the one map course database, and cooperate with the one map core database. We also have the business database, and based on the database, administration platform, comprehensive supervision platform. And also based on this internal system, we can develop the public service platform. This is the data architecture of one map core database. It should integrate management of land resource, such as land, mining, survey, geological environment, affairs, information, and also some others data. And there are some and next is the functions of one map. The first one is a dynamic update of data. The one map system had to support the dynamic update to cloud, and also it should integrate with temporal data, such as the remote sensing image in different year. And it has and next main function is manage land mining source on map, and the real-time tracking project, and dynamic inspection and monitoring. It can management subsystem for violation, enforcement, mining image, and also it has the online management, which to manage all of the land resource on web, such as the planning area, the application form, the approved record, and the work process modeling. And integration of business and the supervision, it mainly has the functions like it mainly has the ideas like the land development and reclamation, approval for construction lines, and the land reserve, and the land supply, and also the inspection supervision. And in the center, there is a dynamic connection between departments. So based on the different level of departments and based on the different type of departments, we draw a graph like this. So it has the different level as country, city, province, ministry, county, city, province, and ministry. And in different levels, they have different tasks to work together to do the land resource management. And it also needs to integrate the existing resource, such as the existing business system, or such as land, mining, geological environment, and we based on the interface to get the data and to cooperate with them to do the supervision and data center. And there are some cases about land one map system, such as this one is in Ganzhou, and it has the data of basic data, thematic data, business data, and the total volume of this data has 1.5 TB. And also, the land resource one map in Ganzhou has a lot of subsystems, such as the automatic office system, the submission application, the examine and approval, the petition, and land register and joint trial. And it has the main functions of like planning, marker, and land classification. Okay, and the last part of my presentation is the SuperMap spatial big data solution. I think Candice, my colleague Candice already mentioned this a bit. SuperMap start to research the big data JS technology from 2017. For the big data JS, we mainly have two directions. The first one is a spatial big data, and the second one is a distributed reconstruction of classic spatial data. And the big data storage is very important. Here I listed some distributed spatial data engine supported by SuperMap, and every one of them has its own feature and different usage. Such as the Elasticsearch, it can support 100 million level data, and it is very good at the streaming data and location data. The HBase can support even billion level of data, and it is very good at to store the vector image data, the multimode spatial query, millisecond response, and super large scale data. So this is one of the example, and it has the 10 million level of data. We draw a polygon to find the data, to find the vector data inside of this polygon, and we can get the response less than 1 second. After the big data storage, we need to talk about the big data analysis operator. Besides of the storage, we also support a lot of big data analysis, such as the spatial big data analysis, like hotspot analysis, OD analysis, trajectory reconstruction, and also others. And also we can support the streaming data. We can support the classic JS distributed reconstruction and the distributed spatial machine learning. This is one of the case about the overlay analysis performance, the comparison between traditional computing and distributed computing. This case is we need to, based on the 22.6 million records data and one polygon which has 3,500 square kilometers. And we need to do the overlay analysis and get the result. If we use the traditional computing, we use the server with 32 CPU cores, and 64 GB memory. Then it will take us around 40 minutes. But if we use the distributed computing with 4 nodes, and every node is only a normal PC, it will only take 2.1 minutes. So there are 20 times enhancement. And the SuperMap iServer streaming data service is another main feature about spatial big data. And here we can see we can get data from different parts of resource, different types of resource, such as from the social media, such as from the mobile signal, such as from the GPS device, and we can import it to SuperMap iServer streaming service, and we can do the filter and map. For output, we can show the data on different terminal directly, or we can also choose to save them to SuperMap iServer data store. This is one of the example. This data is the real-time flight location data, and they are coming continuously based on the stream data, and we can do the filter which is based on based on the main airport to monitor the location of flights. And the next part is about the visualization. Because big data's the data volume is very big, so visualization is also very important. Such as this one is the national land use data, no tiling dynamic rendering based on HBase. We can see it's very smooth. And the static visualization of geographic data, we can use the different shape, different effect to show the big data, and the dynamic visualization of geographic data. We can do the OD analysis, which is original and destination analysis, and also we can show the trajectory of cars on road like this. And this is another capable of receiving and visualizing 100,000 real-time objects per second. And we can show all of them on map directly at the same time. And some others like dynamic expression of density analysis using the heat map to show the location of flights. And the dynamic trajectory of taxis in Chongqing. We can show the trajectory of cars in a very cool effect. Also, we can show the positions of car using the grid aggregation. And this is showing the early peak taxi departure point. All right, that's all the contents of my presentation. Thank you. Thank to all of you for your attention.
All right, thank you, Jason, for your very good presentation about the SuperMap solution cases in worldwide countries for the city development escalation. So now we will have a last session. This is Avela will be the presenter, and she will introduce us about our software, especially in the 3D and AI capabilities. So Vela, can you start to share your screen and open your video? All right, yeah, we can see you now.
All right. Hello. Okay, hi everyone. Did you see my screen? Wait, I will share my screen now. Okay. Can you see my screen now? Maybe Candice can help to say yes if the screen already
Yes,
appear.
yes, it is clear.
All right.
Slideshow, please.
Yep. Okay, so good afternoon, everyone. Today I will share about the SuperMap 3D and also the AI or artificial intelligence live demonstrations. But first, let me introduce myself. My name is Vela Ahala. I'm the technical support engineer from the Asian and Oceania Center SuperMap software. So that's the introduction of myself. And I think we can just go through the first topic, which is the 3D operations. So maybe I will not do any presentations on the PPT itself, because I will do some live demo in the desktop applications. So let's open the applications here. Okay, what you see on the screen, this is the SuperMap iDesktop 10i, which is our our terminal, desktop terminal applications or the product software. So we call it SuperMap iDesktop.net because this is running on the Windows operating system. This is the UI or the interface of SuperMap iDesktop. For the first time, we open these products. We use the ribbon style interface here, and because we will show more about the 3D capabilities, so I already prepared some data about the 3D. Here you can see on the workspace manager, because our SuperMap iDesktop is based on the project file. So we have the project 3D scene here, and inside the 3D scene we have some data. I collected data from other modeling 3D software, which is the 3D Max for the city data. And I also have the DAM data. This is raster data. And here I have the BIM data. This is the building information modeling imported as a Revit data. So this is basically generated by the Autodesk Revit software, and then we import the resulted data of that modeling software to SuperMap iDesktop for the integrations and analysis. So let's take a look on the first one. I will open the 3D Max data. Okay, this is the 3D city made by the 3D Max software. But actually we integrate some capabilities from SuperMap itself. For example, in the 3D Max software, they didn't put any water surface like this, water effect surface like this, but in SuperMap, we have the resources fill library for creating this water surface. So you can see here on the resources, if I click layer style setting, we have some 3D fill symbols, which is the rushing water, slow water, calm lake, and still water. That's depend on the needs or the requirement from the users, which fill that will be selected. Okay. And then here we have some 3D spatial analysis that can be applied using the 3D data. So here in the ribbon menu, we have the 3D analysis, but maybe the first analysis that I want to show you is the fly routes or fly manager. I think on the earlier presentation, my colleague already shows the fly manager tools or functions in the browser terminal applications, but now I want to show you how to do it on the desktop applications. Basically, we create a new stops or a new camera view for creating the routes, but I already prepare it because we only have limited time. So I already prepared the routes. So if I click the flyroutes.fpf, this is the template, and then I click open. Here there will be some stops displayed on the flying stops manager. These stops, can you see this pinpoint? These stops is represented by this pinpoint, and then we can see the settings for the camera, for the directions, for the tilt, and also height of the camera itself. And then we can also set the speed of the route of the video route or the flying routes analysis. So we can play this flying routes. So we can take a look on our design of the 3D models itself. So basically, maybe if you always use the Autodesk software, this functionality is also similar with the InfraWorks video mapping, but this analysis cannot be exported to the video. So this is the first one that I want to show you, which is the flying routes manager, and then I will show you some 3D analysis. That's basically also already being displayed by Jason in the video. But let us take a look on the live demo. I have the shadow analysis here to calculate the daylighting rate for the specific time period in the area. it will generate a sample point based on the sampling distance. So basically, I will draw a polygon here. I draw a polygon for the area of analysis, and then I did the right click to proceed the analysis. So here, you can see there will be some discrete points displayed in the area of analysis, and it shows the daylighting rate for each point. And you can see also we have the classification for the color for the sample points itself. And we can also set the sampling distance. For example, this is 5 meters from one point to another point, and we can set like 2, and it will generate a new analysis based on this sampling distance. So like this, and we can also click this button to query the positions of the points and also the information of the daylighting rate. So that's the first 3D spatial analysis. And we can also do another analysis for design. I think we can apply it in this building. Let me take a look. Okay, this one. We have the feasibility analysis. This feasibility analysis, we can see the area or the point that can be observed from one viewpoint. So at first I draw a viewpoint here on the building, and then I draw the point observed. If the resulted line is green, that means that this point can be seen from this viewpoint. But if the resulted line is red, it means that this point, the observed point, cannot be seen from the viewpoint. So that's the viewshed analysis. Feasibility analysis. And we can also do the viewshed analysis. That's basically the same objective with the feasibility analysis, but the resulted area is different. So feasibility analysis result is only a point, but viewshed analysis result is area. So you can see here, if I draw a viewpoint here and then I drag the mouse or I move the mouse, and here we can see the green area. The green area means that this area can be seen from this viewpoint, but the red area, it means that this area cannot be seen from this viewpoint. So that's how the viewshed analysis work. It's also similar with the dynamic viewshed. The difference is dynamic viewshed can do it dynamically, so it's not static. Let me try to create some dynamic viewshed using this data. I hope that it can be okay like this. This is the resulted analysis. So the difference is we draw the line for the movement of the viewshed analysis. And then you can see here we can create the animations. This is the person animations, and then we can also set the car animations and plane animations. And also we can adjust the parameters like the horizontal here, and also the visible distance and the vertical parameters. So this is the first one, the first data I want to show you, which is the CBD data. The CBD data is based on the 3D Max. Basically, I think the extension file will be .3ds. So you can also import your data to SuperMap if you have the same or the similar extension format. And I also want to show you another data. Here we have the DEM data. I think we have DEM or digital elevation models. So basically, we only open this DEM data in the 2D format data, right? To do the slope analysis, to do the isoline analysis. But in SuperMap, we can also open it in the 3D view using the same software, because we have the 2D and 3D integrated functionality. So here we have the 3D analysis. On this 3D analysis, what we can do using this data, the first one, we can do the slope and aspect analysis. So basically this is simulations or the animations of slope and aspect analysis. So we draw a polygon for the analysis area, and then we click the point and right click if we finish. So the result, it will display the directions of the slope, and also if you want to check the information of the slope, you can click this button, and you can also simulate the flow directions of the flow of the slope directions. And also we can do another analysis. Let me check. We can do what else? We can do the isoline analysis. So the slope aspect analysis and isoline analysis, also the flood analysis, needs the 3D data which has the terrain information. So if your data doesn't have any terrain information, I think the result will be different. So you can see here it will automatically generate isoline based on your parameters here. So you can also set the interval. For example, this is 100. Maybe we want to set it as 50. So the result area will be isoline will also change based on the interval we set. How it will be like this. And also you can see the rendering of our analysis performance, also very smooth and very fast for doing analysis and also displaying the 3D data. So you don't need to worry that your software maybe will be crashed or something like that, because we already handle the performance better for the 3D especially. And also I want to show you another analysis, which is the flood analysis. On this flood analysis, we can draw a polygon to proceed the flood analysis. It will create a simulation of the flood, just like my colleague Jason said earlier on the presentations. Based on the elevations data, we can see which area will happen the flood first, and then which area will not happening a flood. And you can this flood analysis only have the limited parameters. So we only we have parameters of the elevations or the altitude itself from the DM data or from the elevation data, and then we can set the total time, the durations of the flood, and also the speed of the water itself. So this basically the parameters of the flood analysis. And another data I want to show you is this one, the BIM data. So we all know that the BIM data is being grouped by each object or each features. So after we import the Revit data, it shows like this, different features from different model data sets, but we can open it together, right click, and then add to new spherical scene. So the difference in 3D, we add to new spherical scene, not add to maps, but add to scene. And then we can zoom to layer to display the data. So here you can notice that we have the visible sun effect. So here this is the BIM data. BIM data can be query just like the 2D vectors data. Actually, we can query or we can pop up the attributes information inside the properties, and also we can do the SQL query based on this data. So let me try to query maybe like windows on the 8th floor. I use the Chinese sample data, so maybe there's some Mandarin language inside the data, but that's okay. We already know which one. So here I select the Windows model data sets, and the expressions is I will select Windows on the 8th floor only, and I will highlight in the scene and save the result and do the query. Okay, let me try to open again. Okay, let me try to find. Okay, the operator is equal, and then to get the unique value, which is the 8th floor, and then highlight in sync query result 3 query. Okay, now we already have the result, query result 3 for the windows in the 8th floor. Okay, this one, let me try to open in the new windows so it will be clear, so we can zoom clear to see the query result. So here, this is the query result. We only display the windows in the 8th floor. So this is how we do the query for the 3D BIM data. And actually we have still many kind of 3D data that can be opened. So you can see here we can import the point cloud data if you have the point cloud data, oblique photographic data, and also the models data for the geological body or something like that. We can also import to SuperMap iDesktop. But since I only have the limited time in this webinar, I think I only can show some parts of the 3D capabilities. But you can also try by yourself, so you can get the trial version of SuperMap iDesktop for 3 months, and I think it will be enough for you to explore the 3D capabilities of SuperMap. So next part, I will show you how we do the AI capabilities. Okay, let me skip the PPT. Okay, so next we will do the AI live demonstrations. So this AI, we have the Geo AI workflow. The first one, we need to create the training data. We need to prepare the image data and then prepare the label data for the factors for the factor data, and then we do the model building, and we use that model to detect the object or do the feature extractions. In this exercise, I will not do the object detections, but I will do the feature extractions. Sorry. Okay, let me just open the SuperMap products. So this is the SuperMap iDesktop.net. In this .NET versions, we don't have AI capabilities, but we have this AI capabilities in the desktop Java version. So that's different version of desktop product. This is SuperMap iDesktop X. So you can see I will open here. I open the data. Let me try to open it. Okay. Okay. Here you can see on the toolbox we have the machine learning toolbox, which include the imagery analysis. The first steps, we need to prepare the training data. What is the input of the training data? We can double click on this tools, and then we can see we need an input of imagery data sets and also label data sets. What it looks like, I can close this one first, and then I will open the data which I already prepared. So the first one, I have the image, of course. So the objective is I want to digitize this image using the AI, using artificial intelligence. Because basically we do the digitations manually, right? By drawing a polygons, drawing a point, or drawing a line. But using this AI, we can do the feature extractions automatically. But before that, we need to prepare the good models, or best model to do the feature extractions. And I also prepared the factors data here. This is only a sample that will be used for the training data. So after that, we can click this create training data, and then we can put the imagery, the source data set, which is the imagery data set, and also the label data sets. And this one, the picture size, it means that this image, this raster image, this raster image will be split into smaller size based on the size that we define on this picture size. For example, we define 640 to 640 40 pixels. And then on the parameter settings, we choose based on our requirement or based on our needs. For example, on this exercise, I want to have the multiple classifications. So in GeoAI, we have the object detections to detect, or maybe the objective is to count and display the positions of the objects. And we have the binary classifications. These binary classifications only can extract one features in the one processing time. And multiple classification, we can detect more than one type of features in one processing type. And then the scene classifications is to extract the the scene classifications can be used to extract the features in the 3D scene. So now we will create the multiple classifications and the class field. Sorry, I need to show you the class field, what it looks like. So when we create the label data, we need to define the class type. So for the first one, maybe the record, it is the farmland. But the fifth record, this is the building, for example, like that. We need to define the class of our features. And then we can click the class type and multiple classifications. And this is the output path. We can set the output path, for example, like this, and then click run. So I will not click running because the time also limited. So I will just show you the result data. So after we create the training data like that, it will generate like this two folders and one file format. On the images folders, it will split the pictures, slice the pictures into the pixel size that we defined earlier on the training data process. So you can see here, and then we have the mask. The mask will slice the label data. So in the images, we slice the raster data or the image data. On the mask, we slice the label data based on the location, based on the map, based on the image data. Oh, sorry. Okay. After we click this button and then the result is already there, we choose this model training. And then the source data set is the data folder that already being generated after we click the training data, which is this one, training data. And the training model usage, because we will create the multiple classification, we choose these multiple classifications, and then we choose the configuration file. So SuperMap already prepared the configuration file for each detection, for each functionality. For example, we have the multi-class train configuration file, and then we click this one. This is already embedded in the sample data in the package of SuperMap IDX.x. And then we can set the parameters for the Apple and also batch size and learning rate. And we need to create the log folder to see the log information after we do the processing. And then put the result data here. And then click running. After we click running, it will generate the folder like this. Models. It will generate this folder that the model will be used for the feature extractions. So we need to make sure that our model is already fit our expectations. If the model is not the same with our expectations, it means that we need to retraining the models. Maybe we need to add more epoch, and then maybe we need to add more labels data for the training data and etc. After we have the fit models for our detections, then we can choose which type of GeoAI functionality that we want to use. For example, multiple classifications, and then we choose the source data set here, and put the model file, which is the .sdm, and the result data will be appear on this UDB on this data source as a new data set. We need to notice that the data set is in the raster format. So the result is in the raster format data. The result is like this. It classify based on the type, based on the class type. So we have the like building, farmland, and I think this is the water or the lake, yeah, or the water or the river, something like that, based on the class type that we define on the first steps, which is the grid training data. Since we need vector data after the processing of AI, so we need to convert this this result into the vector data. We can choose raster analysis and do the vector to raster conversions, and then raster to vectors. And then we can define the parameters like this to get the vector data. And if I know that the result may be not as good as you do the manual digitations, but it will help you. It will help you to reduce the time or the time to create the digitations. And you can also just using the you can also just do the QC, the small quality control for your data, like smoothing and also factor resampling of your vector data, so you can have the good result of the AI digitations, automatic digitation or automatic feature extractions. So I think that's the demonstration of the AI. So this PPT actually showing the showing the object detection. So in the live demonstration, there is the feature extractions, and this one we do the counting for the palm trees. So this is using the object detections, but the input is the same. We need to have the label data here, and also we need to have the raster data or the image in the TIFF format. We basically use the drone data or maybe the satellite imagery data. And here is the steps of the model building, and also this is how we use the models for the object detections. So that's all for the presentations. Thank you for listening. I think if you have some questions regarding the demonstrations, maybe you can also put the question on the chat box, because I think we have some time for the Q&A sessions if it's not wrong. So I can finish my presentation now. Thank you for all of you.
Okay, thank you, Vela, for your demonstration of our artificial intelligence and GIS integration and the three-dimensional GIS as well. So Vela's presentation, it should be our last session. But before we close this webinar, we will have a very short question and answer session. So I have noticed some questions in the Q&A chat box and also in the chat box. So first question is from Motas Nasser. So he asked about what is the accuracy of contour lines, and the second one is from Mr. Renat Alahmadi, and his question is how I can use oil or gas in GIS. So maybe we can answer the second question. The second question from the Renat Alahmadi. Maybe Jason, can you try to answer these questions?
Yes, hi, can you hear me?
Yeah, I can hear you.
Okay, so yeah, so I will answer the question of how I can use oil or gas in GIS. Actually, I want to explain that GIS is one of the platform, and it can be used in multiple industry. So oil and gas is one of the important industry which can use GIS, and GIS can help a lot. As I explained, talking about oil and gas, we always divide it into three parts: the upstream, midstream, and downstream. So I think for this French, maybe you can contact us by email or by other methods, and we can have a detailed discussion further about your specific requirements. I think that we have the good solution for you. Okay.
All right. So thank you, Jason, for your answer. Okay, the
You're
second
welcome.
question. So the second question is about the counter accuracy. So maybe Fela, can you try to answer? Hello, Fela?
Hello.
Yeah.
All right. So, Mr. Motan Nasser asking what is the accuracy of the contour lines? The accuracy of the contour lines is basically depends on the data we use for the analysis. For example, I think the DM data it's the 25 meter for the resolutions. So I think that the resulted isoline analysis will also be the same, will also have the same accuracy with the data that I use for the analysis itself. Yeah, so that's all I think.
So the Q&A session will be over in just 2 minutes. So this is last question from Faten Nahas. His question is, what is the name of the program that you use for the features extracted and multiple classified? So the program is, the software is the SuperMap iDesktop, SuperMap iDesktop X. So this is our desktop terminal products. We have 90 days trial for it. So maybe if you willing to more to more know about our software, you can try by yourself. You can download in our official website. I will put a link in the presentation. Let me try to share it to you. Everyone, can you see my screen?
Yes, we can.
All right. Oh, wait. So yeah, here is some link you can use to download, the link you can use to download our products in the SuperMap official website. You can download if you're willing to try the SuperMap iDesktop Java version, SuperMap iDesktop X to do the feature extraction. You can download it in the SuperMap official website that I already put a link in this presentation. And it will be 90 days trial version, and this webinar is recorded, so don't worry. I will share this recorded video in our official YouTube, maybe within 2 days later. And also you can download the material of our presentation today in this link already put in the presentation. So it consists of 3 presentations from my side, from Jason, and also Fela. And last, for the participant, you will get the certificate. Please fill the link attached in this presentation to get the certificate, and the certificate will be sent to your email within 2 weeks from this webinar. So last, I would like to say thank you for all of the participants who joined this webinar. We really appreciate that. And also thank you for the speaker. Thank you, Vela. Thank you, Jason, for your very good presentation. And also for Mr. Chuit from the Vision Intelligence and the and Mr. Ali Aldosari from the president of the SGS. Thank you for joining us. Thank you for invite your colleagues to join this webinar. Really appreciate it. And of course, thank you, Evelyn, for assist us to organize this webinar. And last, maybe from Mr. Chuit or Mr. Ali Aldosari, do you want to speak to close this webinar session? Yeah, please.
Yes, thank you, Firdaus. I really appreciate your highly effort to run this wonderful, informative workshop. I enjoy myself, and I'm sure the member of Saudi Geographical Society and other colleagues do the same. Thank you again, and see you in next occasion event. Thank you.
You're very welcome, and also thank you for inviting your colleagues to join this webinar or workshop. And second, maybe Mr. Joey, you want to say something?
Okay, thank you Firdaus, Evelyn, and Villa for your efforts and time for introducing the capabilities of SuperMap Geospatial Intelligence Solutions and Services. And we are looking forward with our partnership to receive any queries, any questions, any future requests to know more about SuperMap in Saudi Arabia. We provide all required support and we can answer all questions for that. Thank you again for Dr. Ali for his support for the cooperation with the Saudi Geographic Society. We believe the geographic community is the base for the development of the geospatial into the country. Thank you all.
Okay, you are very welcome, and also thank you for Vision Intelligence for help us organize this webinar or workshop. And last, maybe from Evelyn, you want to give the closing speech for this webinar? Hello, Evelyn. All right, so I think Evelyn will not give any speech for the closing. So once again, thank you for Mr. Ali, Mr. Joy from Vision Intelligence, and Mr. Ali from the Saudi Geographical Society and King Saud University to help us organize this webinar, this workshop. So we do hope we can gain collaboration in the near future. And last, thank you also for all of the participants for joining this webinar. We do hope you can take knowledge from us. And should you have any question related with our presentation, you can let us know by contacting Mr. Juid or Ali. I hope they will pass your question to us, so we will try to help you answering your queries. So that's all for today. Thank you and see you in the next events. Bye for now.
Thank you. Thank you. Bye-bye.
Thank you.
Bye.
Bye.
Bye-bye.
Bye.
Bye.